Are you sick of encountering exceptions in your application because of null? When you see an exception, does it make you want to scream? Would you prefer to craft your code feeling more relaxed? If so, then join me and learn how to completely master everything to do with null in ASP.NET in under 20 minutes. Here is a fun fact for you. Did you know that since the .NET framework was first released way back in 2002, there's been at least 7 updates to the language just aimed at improving null? Now, granted, a whole video just on null probably isn't going to be excited as watching the new episode of House of Dragons with dragons everywhere and fire and incest. Woo, yeah. However, understanding this stuff is key in order for you to get better with the .NET platform. So what we're going to do in this video is take a complete tour of all the features available to null. We're going to explain things like value types, reference types. We're even going to look at the future and have an overview of a proposed new feature called parameter null checking. So there's going to be a load of good stuff in here, regardless if you're a newbie or a pro. I know one null exception that you don't want to encounter in life is a lookup between my channel name and your YouTube subscribers list. And we can fix that right now with one simple action by smashing on the subscribe button and helping me out with the YouTube algorithm by clicking on like. Ding. Now, not only doing those actions will make you a bona fide legend, it will mean you can level up your development skills by getting notified whenever I release new content. And for doing those two things, as a thank you from me to you, I will show you a picture of a praying mantis. Before we can start considering null, we need to think about the data that we're doing the check against. If we want to store some data within our application, we need to define a type. So common types are things like a number or a string. Now, in all these different types, we have 2 categories. We have one category which are called value types, and we have another category, and these are called reference types. And when I started learning .NET, these 2 things confused me for a while. However, they're pretty simple, and I'll try and break it down for you. Now, when it comes to value types, they're pretty much the basic building block of any single computer application in the world today. So we're talking about things like integers, we're talking things like doubles, date times, chars, all that good stuff. When it comes to value types, the reason they get their name is on how the data is assigned to that type. So when we're trying to assign some data to a value type, a copy of that data is going to be added directly to that type. Now this means that when we're working with value types, we cannot use null, because in order to create that type, we need to assign it a value, and null is not a value. We can prove this, very simple. This is not going to be anything new to anyone who knows C#. If we try to do this int count equals null, you can see that we can't convert null to int because it's basically a value type. So this is a fundamental principle of all value types, they cannot be null. The second category of types are called reference types. And typically these types are more complicated than good old simple value types. Now within this category, we have things like classes, we have arrays, we have strings, we have objects, we have delegates. Now the reason why they're called reference types is that when we're creating a new variable, a copy of that data is not stored directly within that variable in memory. Instead, a reference is stored within that variable. Now, for this video, this doesn't really make too much of a big deal or a differentiator. For this video, we're thinking about null. And the nice thing about all reference types is that they can be null. So this is a big fundamental difference. Out of the box, from .NET 1, value types cannot be null, and reference types can be null. Not being able to use null with value types was super annoying. This is the reason way back in C#2, when generics were introduced, we had the nullable value type. And it does exactly what it says on the tin. It allows us to use null with value types. Now, the way that we create a nullable value type is using this question mark. Using the same code I used earlier, which created an error, you can see that I've got ints, make it nullable by using a question mark, give it a name, assign it null, job is a good. Now, you might be wondering, under the hood, have they completely changed how value types work? No, not at all. Now, this bit of code here is basically nice sugar syntax for this. Now, what this line is saying is that we're still using our underlining value type. This still has to have a value, except for now we're referencing it around a pointer. So we're saying that this nullable type either has to have a value, which is int, or it can be null. And this is the way that we get to use null with value types. So this means that way back from C#2, we've been able to use null with reference types and value types. So we're back on a level playing field. If you thought that was the end of the null story, then my friend, I'm about to rock your world because the saga continues. Now, within C#8, there was a subtle change to how we can access reference types, known as the nullable reference type. Now, one of the nice things about being able to use null with value types is it was very easy to write intentional code. So it was very clear when you wanted a value to be null or was allowed to be used with null. This same luxury wasn't possible when we were working with something like a string. Because a string is a reference type, it was impossible to say this is okay to be mandatory or this needs to contain a value. And the only way that we could do that type of check was some sort of if statement, equality, comparer, that type of thing. Now, this is where the nullable reference type comes into play. Now, as of .NET 6, this feature is enabled by default. If you're using anything before .NET 6 and you're using C#8 and above, you need to explicitly allow this feature. Now, this feature is nothing new, doesn't look too groundbreaking. So let's have a look at it on screen. To define a nullable reference type, we'll be using the question mark or the nullable operator again. We can do that by defining this one example, and then let's compare it to this second one. Now we've got a nullable reference type and a normal reference type. So below, if I did 1 equals null, this is going to be fine. Now if I do 2 equals null, you're going to see I cannot convert null literal to non-nullable reference type. So I'm getting a compiler warning because it's not a nullable type. Now, because this is a change of behavior, this is something which you need to enable. And in order to enable it, you do it on a per project basis. So if I go to my Solution Explorer, if I go to my properties, if I do a search here for nullable, you can see that we've got this option here. So it specifies the project-wide nullable context, only available projects. So in .NET 6, this will be enabled by default. If you're not working in .NET 6 and you want to enable this feature, you might have to come in here and set it for each and every one of your projects. We've now won half the battle when it comes to working with null and .NET. So regardless if we're using a value type or a reference type, we can now be explicit of when we want to allow null and when a value can't contain null. Now, after we've got this capability, this is going to get rid of half our bugs. The other side is actually checking whenever we have a constructor argument or a method argument, if a value contains the data that we expect it to. And when it comes to .NET, we have a variety of ways of actually doing this check. I'm going to go through them all step by step now. In order to demonstrate to you some of the different ways that you can check for null in code, I'll be creating something called a guard clause. Now, if you haven't come across this design pattern before, I recommend you give it a research, especially if you're doing dependency injection combined with solid principles. A guard clause, pretty simple. All we do is put it in our constructors and check that each incoming argument contains a value. If it doesn't, we throw an exception. Now, the benefit of the guard clause is that when we're working with thousands of different objects, if something doesn't have the right dependencies, we know about it quickly. If I were going to create a guard clause within .NET 1, I'll be writing some code very similar to this. Now, in this example, I'm passing in a nullable integer as our arguments. I'm then going to check for null using the equality operator. So I've got if double equals null, throw this null argument exception. If I wanted to invert this logic, so throw an exception if my int contains a value, I'm going to be doing something like this. Now, obviously I can also use has value because we're working with nullables, but the important thing that I want to focus on at the moment is just this double equals. Now, the reason for this is that in .NET 7, we had a brand new operator, which is called is. And is allows us to write this code in a slightly different syntax. So instead of doing these double equals, it's now possible to simplify this using this code. Now, in terms of good practices, it's recommended that you use is compared to those double equals. Now, the main reason for my research for people saying that is because of a very obscure bug, which I don't think anyone is ever going to encounter. However, because we're here for learning, let's look at why using double equals could potentially be a disaster. I hope you're ready for a very contrite example. Now, one of the reasons why we should use double equal compared to is the possibility you might accidentally overwrite things and then create weird behaviors. Now, on the screen, I've created this example class. Now, remember that whenever we're creating a new custom class, it's going to come from system.object to inherit it from. And this means we can overwrite certain base functionalities. Now, in this example, I'm overwriting the equals method. And you can see this because I've got the overwrite operator here. Now, I've also defined an equality operator and an inequality operator. And for all of these examples, I'm returning false. Now, let's say I'm taking this code. So I'm creating a new class and I'm passing in null. And I'm now going to do a check for is null against this object type. Now, in my first example, I'm using the equality operator. And if I look at the value, you can see that this is false. Now, even though I'm passing in my argument here and it's null, I'm doing my null check here, it's saying that this is false, that this actually contains a value. Now, the reason why it's doing this is obviously because we've overwritten these properties and I'm returning false. And this is one of the main reasons why people say that you should use is instead of double equals. So this type of situation can never happen. Let's be honest, it never would, but you know, better to be safe than sorry. In my second example, you can see that I'm using is. And if I'm doing it, my class is null, you can see that this is true. So the is operator isn't going to be affected by any overwrites that you do on any of your custom classes. This is the reason why we should use is. There was one additional update to the framework since the is operator was released, and that happened in C#9. Now, within C#7 or 8, if you wanted to do an inequality check, so if something is false, within the is operator, we would have to write a bit of code which looked something like this. So we'd use the not operator, we'd use some parentheses, which we've got here, we'd put the condition in the middle, and then would negate the check. Now, what happened in C#9 is we had the ability to combine the is operator with the not operator. So as of C#9, we can write much simpler code because we can simply do argument is not null, so it must have some sort of value to trigger this condition. The null checking examples I've shown you so far have all had a cause and effect. So we've been checking if an incoming argument is null or not, and then we've been forming an additional operation, in most cases throwing that argument null exception. And we've been doing this with an if statement. Now, within C#8 and above, we can make this code much more concise by using the null coalesce operator. To get going with the null coalesce operator, we basically just chain two question marks together and then we stick it after anything which could be null, and then we give it an additional expression. So let's see it in action. In this example, I'm passing in a type into a method, and I want to guarantee that this object always contains a value. Now, instead of having to write an if statement or a load of conditional logic on multiple lines, I can use the null coalesce to keep my code really concise. What's happening in this example is that we're saying that if this value 1 has a value, then we're going to assign this into this new object. Now, because we've got the null coalesce here, if this one is actually null, what we're going to do is then run the expression on the right-hand side. And on the right-hand side, we're going to new up a new object. And in this way, we've always guaranteed that this is always going to have a value. Now, the thing about this, though, is that if we're going back to our conditional checks, let's say we want to do a guard clause with our null coalesce. If I wrote this code and then maybe change this to new throw new argument exception, go like that. As you can see, we can't do this. We're going to get this error, only assignment calls, increment, decrement, blah, blah, blah. So we can't actually put this in our classes on its own. Now, if you wanted to use null coalesce as a guard clause, you can using something called the discard. So the discard operator came out in C# version 7, and it does what it says on the tin, basically just ignores patterns. So give it some values, it's going to ignore it. Now, what we can do with this code is refactor it so it does this. What we're saying here is that here's our discard pattern because we're using the underscore. What we're saying is ignore basically this. We're assigning it to discard, so we don't have any variables. We're not wasting any memory. And what we're saying using null coalesce is that if we have this one object and it's populated, brilliant, move on to the next line of code. If this one thing is null, we're then going to trigger our guard by throwing this null argument exception. Personally, I really like how minimal the code ends up after we combine discard with null coalesce. However, I don't really tend to use this technique in production. And the reason for this is I personally think it leads to a more complicated code base. Now, let's be honest, we can't get rid of using if statements. They get used everywhere. And what I found is when I started using this technique, I'd have some classes that had an if, some classes had a discard with a null coalesce, and what happened was more junior members of the team struggled to actually understand what the code was doing. When you're introducing different techniques to do the same thing, you're just adding extra complexity. So think about it. The final feature that I would like to tell you about isn't actually available within the framework currently, and it probably won't be within 2022. Now, this feature is called the parameter null check. And the reason why I'm including this right at the end is because if you do some Google researching around null, it's very likely you're going to see code which contains this example. And I don't want you to get frustrated at home trying to implement something, wondering why your code doesn't work. Now, I really hope this feature gets introduced. As we've gone through all those guard checks so far, you can see that we've had to create a if statement, or we've had to use discard with null coalesce, whatever makes you happy. And the parameter null check will save us from writing that code. All we need to do is on our input arguments is postfix it with a double bang. And when we have this set up, what the proposal says is that this is going to throw an argument null exception for us automatically without us having to write anything, which is then going to say, argument 1 is null. And apparently we'll be able to chain it with a nullable operator as well, so we've got loads of good bits. Now, as you can see, the parameter null checking feature is not supported. Obviously, it was supported at one stage because how would this exception message know about it? I'm currently using .NET7 preview with C#11, and this feature used to work. However, with an update from June 2022, this feature is broken. It's been pulled from C#11, so hopefully in C#12 it will work. But if you come across this type of code and you wonder why you can't get it working, it's because it's been scrapped. So let's pray for the null checking gods in the future, they add it back in. That covers pretty much everything you can do with null and C# up to this point in time. Now, it's quite amazing that we can do a whole 20-minute jam-packed video just on how we can work with null. However, as you can see, there's a lot to it. I'm hoping that you've gained a few nuggets of wisdom from this, and more importantly, you can write more defensive code. You don't have to put up with that null exception error in production, so you can be an absolute champ at work. Now, if you have enjoyed this content and you have learned something, there's a few things you could do to help me out. One, you could just leave a comment, say that you enjoyed the video, give me some information about what you'd like me to deep dive into .NET Core next. You can obviously hit the subscribe button so you can see my weekly videos every Sunday. The final thing you can do is help me out by clicking on like. It takes me a lot of time to record, research these videos, so you don't have to do all the hard work yourself. So clicking on like just basically helps the channel to grow, and I'd appreciate it. Otherwise, if you want to stay up to date with me, I do a Sunday newsletter, which is linked to below. Otherwise, I hope you're having a fantastic day wherever you are in this world. Until next Sunday, happy coding.